So let's explore some other vector spaces. To do that, we're going to define something here. Suppose that set V is a non-empty subset of Rn. Now remember, we know Rn is a vector space. It has all those lovely properties. And suppose that V is also closed under addition and closed under scalar multiplication. So we know it has at least those two properties. Then we say that V is a subspace of Rn. Okay? And here we call it a subspace because it turns out it is a vector space that would be a subset of Rn. Now, remember a vector space has all these nice properties, right? Notice in this definition, we're only mentioning two of them. We're only saying closed under addition and closed under scalar multiplication. It turns out, though, that if V is a subset of Rn, a lot of the properties that hold for Rn also hold for V. For example, commutative property of addition. Now, for any two vectors in Rn, if I add those two vectors together, u plus v, that's the same as v plus u. Okay? But if I take a subset of Rn, that means v is some section of Rn. So if this is Rn, for example, then v might be some piece of it. Okay? Not all of it, but some piece of it, which means everything that's in v is also already in Rn, right? Which means if I take any two vectors in V, they must also be commutative when I add them together because any two vectors in V would also be vectors in Rn. So this property automatically holds for a subset of Rn because it holds for Rn. Okay? Same for this. This holds for all vectors in Rn. Since all the vectors in the subset V are also in Rn, this property also holds for V. That's true for almost all of these properties. Almost all of these properties hold automatically for any subset of Rn. But the two that we need to check, the two that may not hold automatically, is that Rn is closed, that the vector subset is closed under addition and closed under scalar multiplication. And so those are the two we have to check. If we want to check if a subset of vector space Rn is a subspace, in other words, it's a smaller vector space, then we need to make sure that this set is closed under addition and closed under scalar multiplication, which means we could ignore most of this. It just kind of comes along for the ride. We just have to check these last two properties.